Ritukar, do you want to just introduce yourself while we're waiting for a couple more people to join, and then we'll get you to do that again when the webinar starts.
Yeah, sure. So, hi everyone. First of all, thanks for taking out time for today's session. Briefly, if I have to introduce, I've spent almost 16 years in autonomous driving and robotics. My career started with, hobby robotics for college projects, but then turned into a mainstream career. The first stint was around, defense robots, unmanned ground vehicles, then forayed into, warehousing and material movement, in manufacturing facilities, mobile robots for that. And since 2016 onwards, I've been truly focusing on autonomous vehicles. Just before starting Ottonomy, I was living in Germany, working for a company called Aptiv, where I was leading BMW's urban autopilots. It was pretty much that time when we realized that autonomous cars will take more time to hit the mainstream, and not because of any technology gap, but also because of a lot of regulatory and public perception aspects. So myself and my co-founders, we came together and started Ottonomy from a single perspective, that how can we put these robots out in the public and solve a few of the near-term goals for next 3 to 5 years, which are very, very important. That's how we focused around deliveries. So as we speak now, I mean, it's almost slightly above 2.5 years at Ottonomy, and it has been a very fulfilling journey where we place these robots out in public, places like airports, malls, and also hyperlocal space on the sidewalks where these robots can deliver goods, right? Be it food and beverage, retail, or packages, parcels. So that's about it, and we'll talk more as we go along. But a few of the things which specifically are very, very interesting is that in last 2.5 years we were able to put these robots in different geographies, North America, Middle East, and Europe. So there are a lot of learnings from different market segments, that what do they need, and what is the gap. And that's how we got associated with Urban Robotics Foundation, to in an effort to standardize public robots. So that's about it. That's about me, and the intent of having this webinar.
That's a wonderful introduction. Thank you so much, Ritukar. Well, we are recording this, so I think what we should do, Bern, is go ahead if you're okay with that, and I'm going to, yes, you can hear from my voice. I apologize. I'm not going to talk a lot. I'll be on mute, but I will be monitoring the chat. And I'm going to be running the slides for the team until Ritukar's turn comes. And then Ritukar, you're going to use your Canva to share the screen. So I just want to introduce myself. My name is Lee St. James. I'm the Managing Director of the Urban Robotics Foundation. And I'm happy to be here as your sort of MC for the event. And what I'm going to do is I'm going to just quickly go through the agenda and then hand it over to Bern. So basically, the intention of the Introduction to Municipal Readiness webinars are to help you understand what are public area mobile robots and what are they not. What are the challenges that we see, and why, sort of why does the Urban Robotics Foundation exist? Then we're going to hear from our guest speaker, Ritukar, who just gave a short introduction to himself, but we'll talk more about Ottonomy, and he has a great presentation lined up. Then we're going to do an audience Q&A, and then if we have time at the end, we're going to talk more about the work that we're doing with the Urban Robotics Foundation around the international standard 4448 for intelligent transport systems, which includes public area mobile robots and automated pathway devices. And then our upcoming publications, the municipal guides to public area mobile robots. But it really, this is a huge opportunity for everyone to hear from Ritukar and what Ottonomy thinks about this whole area of municipal readiness. So Bern is going to take you through sort of an introduction to PMRs, and then we'll hand it over to Ritukar in about 10 minutes or so.
Perfect. Thank you, everybody. I want to introduce what public area mobile robots are. They're any robot that is either ground-based or on wheels. They are always unmanned. What unmanned means is there's not a person near them. Where you'll see in a couple of these images, a person nearby is in the upper left, that person simply walking in that same space. And on the lower right, that person happens to be taking a delivery, but there's no humans present. They might be teleoperated, but they're always in public spaces, pedestrian spaces, all sorts of indoor and outdoor. But what matters is that there's pedestrians nearby. These devices do all sorts of tasks, delivery, which we'll hear about today. They do maintenance, surveillance, monitoring, and so on. Any task that is amenable to robotic actions are included. Out of scope are anything in a structured environment. I'll talk about that in a moment, but those that are working in warehouses and manufacturing, those that are working on farms or in mines, for example. Aerial drones are not included. Electric scooters and e-bikes are not included. So it's not just because it's a small thing on the sidewalk. It's robotic, and it is on public spaces, and it's on the ground. Those are the important issues. Structured environments, which we know a lot more about, which have been around for a long while. I mean, robots have been around for 50 years, but they've been in heavy commercial use for the last sort of 10 or 15. But in manufacturing and in warehousing, now if we want to move them to the sidewalk, and here's an extreme case. On the right is an extreme example of a very obviously very difficult place to navigate. This just shown here as a horrible example of an unstructured environment that is not designed for robotic use. So that's the major difference. So here is a sequence that was filmed fortuitously. It's a really wonderful film that we have that shows a series of events that happened. On the upper left, this robot was stopped in the crosswalk, and you can see very, very far in the distance another similar robot coming up in the same direction. And that second robot, when it arrives, tries to push that first robot out of the way. That first robot was stalled for some reason. We don't know the reason. Then a pedestrian came along to sort of try to help out. Try to consider that we ought not to have pedestrians volunteering to move these devices because there's insurance concerns. A second pedestrian came by to help out, which makes it yet more complex. And eventually they were repositioned on the pavement, on the sidewalk by the two pedestrians, but they're in the area where the ramp is that would then block wheelchair use. And finally, somebody from the company came along to move one of them away. Anyway, the point of this is that we need a body of rules that minimize this kind of event ever happening, that minimizes pedestrian involvement in moving and rescuing these devices because of the insurance concerns and because of the safety for other pedestrians in the proximate to the robots. Here's another case where this is the same robot that was waiting. It finally decided to cross the crosswalk or cross the intersection, and it did so correctly. It did so on a green light, and while doing it, a car blocked its path. And then, of course, show the next slide. When what happened then is that the robot it's dangerous to turn around and go back because maybe the light is going to turn red. But so this robot chose to go around the vehicle. And of course, it did that by going out in the area where a cyclist might be traveling and so forth. So there's these kinds of things that the standard is set up to avoid or help write bylaws about these kinds of things. So this is talking about all forms of human mobility challenges. So we often consider wheelchair and blind as obvious. This is a case of a disorder called kyphosis, where this pedestrian cannot actually stand up straight and cannot see very far and forward. So in this case, and this person is not blind, as far as we know, is that a PMR could block her path. It could alarm her as it comes by her. But the flip side of this is that PMRs could deliver groceries to her, or a PMR in the form of a follow me PMR could carry her bags for her, for example. And while doing so, could actually help protect her because the PMR would be able to see further than this pedestrian could. So the net of it is, how do we have the world collaborate or help people with mobility challenges while serving them, and make sure that we don't alarm or harm them while we're operating on the sidewalk. So that's a dual case. So very quickly, we were founded just about 2 years ago now, and we work in this. I think you can see it's urban space and accessibility, as I just showed in the last a couple of slides, and these mobile robots. The draft of the standard that we're working on, we are the project managers of an ISO standard that Lee has already described to you. That draft is to be published in 25 and 26. There's 16 parts to that draft. I'll talk about that at the last slide if we have a few minutes. We are publishing a municipal readiness guide book that will start early next year. Those are already over half written. And we deliver workshops and educational materials, advisory services as well for those cities that are setting up pilots and trials and so on. And I underscore that we are a global organization. We have members in many countries around the world, and we are a nonprofit. Our goals are to strengthen stakeholder readiness. Stakeholders mean, and we'll show you in a moment, not just the roboticists, but the municipalities, planners, traffic planners, and so on. And our principal goal is to prepare urban ecosystems for these PMRs in these pedestrian spaces. So, of course, it's important that these standards are well constructed, that they're consistent, that they are focused on project and deployment designs, that they always are focused also on greater accessibility and safety. And we're seeking acceptance from the populations of people that these robots are operating in, and altogether to have improved city livability, better cities. So our members, you can see here, include government planners, because our writing is geared toward government planners and sort of smart city public works sort of things. Public facilities as well, hospitals and airports have pedestrian spaces within them that these robots operate on. In fact, our speaker today, their robot frequently operates in airports, like inside an airport in that pedestrian area where passengers are occupying, waiting for flights and so forth. We're concerned very much about accessibility, as I think we've made plain in a few slides ago. Technology companies such as Ottonomy today is considered a technology company. Also fleet operators, in this case, that Ottonomy also operates fleets that they built themselves, so they sort of do both roles. And of course, we have researchers as members as well. So how this works together, why there is on the left this issue about standards, and you can see some of the standards of mapping and orchestration and safety and certification and so forth. It's all sort of technology oriented, logistics oriented, operations oriented, and it's all about improved delivery of technology, not delivery of food, but also that. In any case, on the right, with the guidebook, it's really about governance and livability. And in this case, it's to boost urban confidence. So how these two work together in the middle, on one hand is industry, on the other hand is cities. On the left is technology, on the right is projects, on the left is methods, on the right is regulation. So these are the pairings of the concerns for two sides. These pairings have to match, and that's our fundamental goal. What we are doing is those four lines in between these four different expressions of goals to create an environment where these are safe, valuable, commercially viable, and livable. So as a member, our principal activities are to help you get prepared, help you to anticipate the impact. Again, this sentence is for municipalities and planners. The roboticists are getting themselves prepared. They don't need our help to prepare themselves, but cities and planners do. All of our members help shape the international standards, and they also help shape the guidebook as well. And critically, our members can network. Today is one example of a potential opportunity to network, in the sense that you can meet each other and you can engage offline, of course, but that networking is a very important part of what we do. So let me stop now. You've met Ritukar a few moments ago. Let me just turn it over to you, Ritukar.
Yes. So, hi, everyone. I think I gave a brief introduction about myself. So, if somebody else has joined, so I'm the co-founder and CEO of Ottonomy. And what we do is we develop these autonomous delivery robots for deliveries in hyperlocal space, be it indoors and outdoors. Now, one of the most important reasons why we are doing this is, more focused around, labor shortage. And at this point in time, specifically after COVID, what has happened is, one, there is labor shortage already, but now a lot of people have repurposed themselves to other roles. And because of it, there is a specific deficit of people who can do deliveries for you. And because of this shortage, what has happened is that there is a substantial amount of increase in wages, which is more than 100%. So just to give some context there, before 2021, the hourly wages were moving around $9 to $12. But at this point in time, the running rate is $18 to $25. So it has not happened in last 15 to 20 years, and maybe more, that there is 100% hike in a very small duration of time. So it's very critical, and something needs to be done around that. And it's not a function of that increased wages is the core problem, but how it results is either for the enterprises or for customers like you and me. When we order something, we pay almost $7 for a $10 burger, and we add $5 tip, so we end up paying $22 for a thing which is worth $10, right? So from all those aspects, I think this is an interesting time to put these robots out in public. Obviously, we have our customer base spread across retail and logistics, quick service restaurants, and airport malls and casinos. We were the world's first to do any autonomous deliveries at airports, and it is very interesting that how multiple aspects comes into an airport environment, right? So broadly, what we do is we have the same set of robots which are doing outdoor deliveries and indoor deliveries. So when we talk about outdoor, these robots are doing hyperlocal last mile, which is anything which is in a radius of 1.5 miles. And while doing this, the robots are navigating on sidewalks or crossing streets, right? Also, these robots are doing indoor to outdoor maneuvers, like bringing items from inside the store to the parking lot, which is for automating the curbside pickups. At places like airports, malls, and casinos, it is actually doing deliveries from the kitchen to various locations within that large area. And also this is heavily strained because customers want delivery, but people are not available to make those deliveries for them. So that's why the need comes around. Just a brief on the robots. These robots are L4 autonomous. Now, when we say L4 autonomous, it doesn't mean that these are like 100% autonomous. These are 99% autonomous, because the environment in which they operate, it is very dynamic, and there can be certain edge cases, right? But the overall approach towards solving the mobility aspect is to make the robot fully capable of doing autonomous navigation. Now, for certain edge cases, we have a fallback teleoperation, which we'll talk about, and that's why this is L4 autonomous, not an L5. We can integrate with any aggregator, any apps to facilitate different type of deliveries, and these are indoor and outdoor, as I said. I'll just play a brief video that will give some context about what these robots are capable of, or what they have done in some time. So we have tested with our customers in different locations, different environmental conditions, different use cases, where you see these robots during a snowfall, after the snowfall, inside airports, which is a completely structured yet dynamic environment, on the sidewalks. And these deployments are spreading across multiple geographies, right? So North America, Europe, and Middle East. And apart from the fact that there are certain different regulatory frameworks, even the demography changes, people perception, their expectation also changes with change in geographical setting. Now, Also, I mean, it doesn't stop there. So one thing which we figured out was that, we wanted to do multiple deliveries in the same trip. So, we need to have slightly larger robots. But the problem with larger robots is that, maneuvering in tight spaces is really tough. So we came up with a specific drivetrain, which can, move sideways, doing a crab walk and take 0 radius turns. So also, when we talk about food deliveries, you are always there to take it. But when we are talking about, parcels, somebody from, any of the logistics companies might be throwing to your gate, right? So how can we, navigate that aspect? So all this is taken care by these robots, and we call them Autobots. So these robots are, as I said, like scalable. So you can have multiple configuration based on business needs. So it can be lockers, it can be, one large compartment for groceries, or, 8 to 12 compartments for parcels, small parcels, right? So we designed the robots in such a way that, the robot stays, but the use case or the business can customize it for their needs, right? So broadly, as I said, like earlier, these robots are, fully autonomous using contextual navigation for both indoor and outdoor environment, which works without GPS, but also has a, fallback teleoperation where, you can always monitor what is happening around the robots, or the robot will give you an alert that, hey, I need help. And I'll tell you why this is important when it comes to today's topic, that, regarding standardizations. Also, one of the most important things which we kept in mind was, apart from all the technology and, different aspects which we discussed right now, we had like accessibility as one of the most important things, because what we are doing here is we are sharing, sidewalks which are meant for people, which were originally designed for people. So if we are sharing those areas, then we need to have, mechanisms, or make these robots, capable of assisting them at the same time. So when we design the robots, it is made sure that people on wheelchair or, special abilities can access those packages comfortably. Now, this was like about all the scenarios or all the, things which we did. Now, when we put these robots out in public, there are so many different scenarios of the real life issues which we face. Now, on the left, the picture which you see is at Pittsburgh Airport, where, as you can see, that there are 2 small young kids standing next to the robot. Now, obviously, when we are running these robots in public areas or public places like airports or malls, you have, kids roaming around, they're playing, and the robot has to, not only detect or avoid them, but also to have certain behaviors that what is, safety to the entire ODD, right? So I'll give you an anecdote there that once we were doing initial pilots with Cincinnati Airport, the robots were, moving, and there was a kid lying on the floor crying, right? So we were like literally, thinking that, oh my God, this is something which is a very specific edge case. But fortunately, when we went ahead, like, we made sure that obstacles up to 10 centimeters of, height are detected, and robot can take some, at least stop in that case. So it was safe. But then again, when it comes to different type of behaviors, we need to have more standard rules and regulations that how, different people or, be it elderly, wheelchairs, and, kids, how the robots can have different behaviors, and what is safety defined in those areas. Because if you look at, adjacent standards, which are for warehouses, which are for manufacturing setups, you won't see kids, running around an autonomous robot, right? Second example I just want to give. So this is a place called Peoria near Chicago, where these robots are crossing the road. Now, as you can see, it does have, the pedestrian crossing lights, but there is no other, signs of, that this is a crossing, right? No zebra crossing or anything of that sort, right? So these are next level of challenges where, the robot has to make sure that it crosses. And one interesting thing, which I don't know if somebody has noticed, a gentleman here is crossing the road diagonally. Now, some places in the US, specifically, I've seen in Peoria, I've seen in Pittsburgh also, that there is a crossing where you don't have to there's a provision of doing a diagonal crossing as well, which is slightly bizarre, but that's how it is. I mean, there's certain places which do that. Now, this is not in any of the traffic rules, right? So you won't see this in Europe, you won't see in Middle East, but even in US, very specific locations. So how do we comprehend? How do we, adjust to these changing environments or situations, right? So that's another, a specific example I thought is very, very important. Then we see a lot of other examples, like here, crossing the roads when people are coming in and, walking next to the robot. In this case, the robot is moving in a sidewalk where other people are moving. And if you see that the robot stopped and there was a person with a stroller, right? So that is another, what does safety look like, and what are the parameters, like here people let it come back again, loop back again here. So yeah, so this was the place where the stroller was detected from an edge, and people stopping next to the robot still stops, slightly moves, adjusts, and then move. So this was all, there is no standard for these type of scenarios, right? Another thing which we have is, I'll just come back. So, municipalities, like, as you see, this robot here is literally, climbing the curb. Although it is, it is a crossing, but it's not ADA compliant. I'll just put it simply. It's not ADA compliant, crossing. The robot are managing those, but there is no, guidelines from the municipality also. What if there was a wheelchair who wanted to, person on a wheelchair who wanted to cross the road? It is literally impossible for them. It is a lot of movement for them. So, and the important thing is that the municipalities are also not aware that how many places are like, they do a periodic check. But if there is a mechanism, these robots can give them live data that, hey, this is something where, you can focus on in the next quarter or so to make it, to increase your ADA compliance coverage. So that is something which can be given. But again, there is no standard for that, right? So there is no meaningful exchange of information which can be shared with the municipalities. And then last but not the least, what you see on the, right bottom is, the monitoring suite. So we have these robots which are monitoring, and, this is more of like brought in just for the sake of this conversation. So how to make sure that the data which is there for the monitoring of robots is secure, and how do we maintain cybersecurity and other aspects so that, that is also covered. So all those aspects, they not only, require, but they are shouting out for a standard, right? So now, obviously, road crossings, as I discussed about road crossings, but there are, there's a, infrastructure element also, that there are certain parts, in the US where you have to press a button to either prioritize or even to, enable, the pedestrian light to turn green. Now, with robots, nobody's going to press a button. You need to have an interface with the infrastructure to, communicate with it, right? And we've been talking about V2X in autonomous cars since a long time. It's all like, talked about, a lot of standards, but this is a real need right now. I mean, this has to be, there is a button which needs to be pressed, and, there's nobody to press it. So imagine 11 p.m., the robots are waiting at a street light that somebody will come and press a button so that I can cross the road. So there is no V2X standard for these kind of, things. And there are companies who are working, but still that's something which is open. And we discussed already, kids, behavior around kids. How do we define safety? Now, since I touched upon infrastructure, so there is another thing which I just wanted to share. I'll just quickly move this video. So this is our New York office, and we are doing some integration where these robots are navigating on the sidewalks, but also coming up, interacting with the new functions or new type of infrastructure elements which can be required. So here what we are doing is we are talking to a smart mailbox. which is again an infrastructure element, where the robots are directly delivering into a smart, mailbox. So the robot comes in, aligns to a smart mailbox, and then, delivers the package to the mailbox. So the door opens at the mailbox, the robot just puts the package inside the mailbox and go away, right? Now, obviously, I mean, these are all new things, and this is just one example that there'll be more coming, right? So the same, mailboxes are new set of infrastructure elements which can be brought in and which can be talked about. So, but again, there is no standard for that, right? So, I mean, now we look at like what is available in the market, what we have been dealing with, right? So when we talk to different customers in different geographies, so we were talking to a customer in Southeast Asia. So what they gave, like, hey, there is no standard for delivery robots. So, but why don't you comply to ISO 13482, which is a personal care robot standard, right? Of course, I mean, how they see it is that there are robots, there are people. So whatever personal care robot standards are, you should comply to that. But it doesn't make sense because these robots are running outdoors, and how can you define safety compared to something which is somewhere else in complete different ODD. Okay, so they're doing it because there is no standard, so they're doing their best, and we kind of identify certain segments just to make it work, but it's not so clean, right? Second, in Europe, all the robots have to be CE compliant, which is absolutely fine. There is no issues on that. But then just being CE compliant is not 100%, covers the certification process or the standardization of the operations. Then few of the customers also came around like, hey, do you comply to ISO 26262 because you are on the road? So we then try to make them understand that, hey, ISO 26262 is for autonomous cars. I mean, when the vehicles are running on the road, they're not running on the road. We are just on the sidewalks at less than 10 miles per hour. And, we only cross the roads. So then we have to make them understand that we don't have to go through the automotive standards, So that's why, this becomes so important because everybody's trying to align to some sort of an adjacent use case. And people also, use the warehousing robots as standard, mobile robot standards as well. So also I'll take you a little deeper, of the disconnect. So, if you look at the United States, there are 20 states who have passed bills for these personal delivery devices. That's what in the legal legislature, they call it PDD. And if you see, all of these are like, they have some difference from one from other. Some, allow only 100-pound robot. That is the weight limit of the robot. Some allows 550-pound robot. Some goes till 10 miles per hour. Some, goes 12 miles per hour and so on, 7 and 6. So although there is some, regulations which are there, there has been a constant effort by not only, the states, the municipalities, but each municipality has taken based on their judgment, their understanding, and their interface with which company is doing trials or pilots in their city, right? So they came up with a standard, but imagine if there is a large QSR or a large retail company in the US, which they are present in all 40 plus states, and they want to scale. They did pilots in one state, but they want to scale their operations. Imagine the amount of work which they have to do to scale it across the state, right? Because each state has different regulations. So this is, why I'm bringing this up is that, although a lot of municipalities have done wonderful work, even to get to this point, but still, there has to be some uniformity which has to come in, and there, URF can play a wonderful role there. And on top of it, the onus comes to the robotics delivery service provider that, hey, you figure out the regulations, you should be allowed to run in those places. I'm present in 40 states. If you go along with us, you have to, take all the approvals. And based on cities, states, and countries, for example, Middle East is coming up with their own standards, local regulatory, understanding of, things. So because they don't have any a specific ISO standard, which gives them the, infrastructure to maybe take it and absorb it and then customize based on their, specific needs, right? Over and above. So that's where, that is our learning, that is our, observation over the period of time. We have deployed fleets in the US, in Spain, Rome International Airport, Cincinnati International Airport, Postal Department of Norway. Also, we ran these robots as, for the police of Peoria, Peoria PD, as surveillance robots, just to help them and get the, if there is any, shooting happening. So how can these robots be the first responders? So, but in all the scenarios, I mean, these robots are pretty much out in public, right? So that's why, we see that there is a lot of new things which needs to become, which needs to be done here. And, we have been doing what we can do to make deliveries what it should be like for all of us, specifically when we talk about public robots. So right from 2021 till 23, we made it to Robotics Business Review top 50 robotics companies. And, all this is good, but the important thing is that there were very less public robots in the list, okay? Most of the robots were, in constrained environments, in warehouses, automation, factories, and all that. Even NASA, JPL, and other companies were also in this, top 50 list. Now the public robots are getting into the mainstream; they are getting absorbed, and so there's a long way to go. Also, apart from the deliveries, the first responders, these robots have a huge impact to be played in sustainability aspect. Specifically, why do you need a car to deliver, your groceries? I mean, which can be done by an electric robot, right? So I think from all those perspectives, this all makes towards our effort for more sustainable future. So that's the team. I mean, that's 4 co-founders who started this company, in midst of COVID. Looked at the adverse impact of what a completely unexpected pandemic can do. We tried to turn it upside down into an opportunity, how we can do something meaningful. And we have been backed by our investors and advisors to do what we are doing at this point in time. So that's about it. I think I hope that this session was connected some dots, and if you have questions, please feel free to ask.
Yeah, thank you so much, Ritukar. That was really fascinating. What's interesting, and for our audience, is that some of the things that you mentioned as edge cases are being addressed in the 4448 standard, but not all of them. For example, one of the intersections that we didn't consider is the diagonal intersection, which we have 2 of them here in Toronto. Thank you. That has to get in. I wanted to ask you a question before we turn it over to the audience. Is that mailbox yours? Because the design of that mailbox seems to fit so well with your device.
Yeah, I mean, it is a pure coincidence. There's another company called Arrive, which is they're using these mailboxes to transfer data from the robots to the mailbox, and from the mailbox to the robots also. Okay. And on the top, they have drones which can drop the packages in the mailbox as well. So that's kind of a smart mailbox which they're working on. So one fine day, we they were neighbors to one of the events, National Retail Federation conference. We exchanged cards, and like 1 year fast forward, we met in New York. They had the smart mailbox, and we in 2 days we did the integration to make it realize that this is what it is. I mean, this is how things need to be seen more visibly.
Yeah, the mailbox robot interface is not standardized either, and it was a relatively reasonable match when you showed that. So I thought maybe there was more work being done in that area, but that's a pretty important. I think everybody can see that the number of things that need to be done standards-wise is huge. I mean, you listed a whole bunch of things that are missing from 13482 and 26 and so on. And you are right that 4448 is intended to fill most, not all, but most of the gaps for companies like yours and for cities that want to admit or certify devices like yours. Lee, do you want to ask questions from the audience, I think, right now?
Yeah, thank you. Bhavisha actually had a question. Do you wanna open your?
Yeah, sure. I was just asking, so I think I understand the importance of standards. You gave a great context in terms of trying to adhere to different standards and why they're not applicable in this case. So that was very beneficial. What I'm trying to get at is, there's got to be other factors present when you are successful with certain cities. We know municipalities move at different paces. There might be different factors involved, but are you seeing something from a technology provider perspective that's consistent across all the 40 states where you are present, or in environments where you can be successful? Is there anything that stands out in terms of what's making that possible that perhaps other people could learn from?
One of the most important things is, which is common at all the locations, is liability. And, that's where everything stems out, that who is liable if something goes wrong, right? And that's why municipalities, a few of them passed the bills. And for example, I'll give an example of Houston. So in Houston, you just have to, inform the municipalities that you're doing a pilot, and that's it. I mean, as a protocol, you just have to inform. You don't have to do anything else. Now, at the same time, broadly, what they're concerned is that these robots should not harm people. And if it harms, then, municipalities they want a clear language that who is liable and how do they protect people, right? So that's an adjacent area, which is insurances, right? So liability insurances, and safety insurances for the robots also. I mean, there's a other way around also. So they're like some, you would have seen very recently, there were autonomous cars which were like literally broken by a baseball bat. And there were robots on which people started sitting and just playing around. So I think that aspect. So first concern is liability for people. The second stage which we are getting into is that there are so many notorious things happening. So liability of the robots, because these are like sophisticated machines which are mimicking human behavior to navigate autonomously. So I mean, these are two common things which are like needs to be solved over the period of time. And also awareness within people that it is there for their good, not taking away anything else.
Can I add to an aspect to Bhavisha's question? My observation about insurance in some of that U.S. legislation, some of that U.S. legislation says $100,000 for the fleet or $100,000 per device. There's a conflict there because you listed some conflicts among those. And I've also seen up here in Canada and in another place, I can't remember the city it was at, where they were asking for insurance of $5 million per device. Okay. Have you seen ranges like that as well?
So what we've seen is like overall coverage of $5 million, when we are deploying robots. And, for example, if we are doing it for a retail company or, a QSR, we need to add them into the insurance that if there is some some mishappening happens, then they got it covered through our insurance. So a 5 million cover and a couple of instances and all that. So yes, I mean, that's true. It's not in thousands, it's in millions. So that's the coverage which they need. And exactly, coming back to the same point that people are trying to protect that who is responsible. And this is going to happen like at the starting, but over the period of time, if a person has an accident with a robot, then the insurance should be on the both sides. Even the robot should be covered by your car, because you hit the robot. So I think there's a lot of more business which is going to happen, but it'll take its own sweet time.
Yeah. Thank you.
Hi, this is Pat Hilberg. Am I on?
Yeah, and then we'll Harshal, you're next. Yeah, go ahead.
Oh, I'm sorry. I didn't mean to jump.
That's okay. Go ahead, Pat.
Okay. Yeah. I've got two things actually. I'll start with the second thing, which is the liability question. A good person to follow on this is Philip Koopman, who's at Carnegie Mellon University. He and a law professor out of University of Miami, just released something last weekend where they're pushing towards the idea that it should not be a product liability concern, it should be a driver negligence concern. So they're promoting the idea that the autonomous vehicle needs to conform to existing driving laws, and judges and juries can quickly figure out whether or not they conform to a driving law. And then the autonomous driver becomes responsible within driving laws.
Right.
In fact, one of the pieces that they bring up is that there's just not enough expert witnesses to handle, even if there's a 90% reduction in automotive deaths, there's not enough expert witnesses to handle product liability cases. So you really need to push into negligence cases. Now, a point I brought back up to them, which I don't think they've really answered, is yes, but when an individual shows negligence, you can address that problem by taking that individual off the road. If you have 1,000 or 1,000,000 or 10 million autonomous vehicles, one of which shows negligence, do all 10 million need to come off the road? So that's a question there. I'll kind of let you don't necessarily need to answer that. I'm just saying, follow Philip Koopman, or you can follow me because I'm always talking to Philip Koopman. I teach a course in product life cycles. Most of my students, it's a graduate course in product life cycles, engineering management. Most of my students are in the automotive industry. Most of them are working in either autonomous vehicles or battery electric vehicles. And this is the end project that we work on is, let's assume that we monetize external costs, meaning I'll jump to the head a little bit and say the price of gasoline hits $100 a gallon and will never come down from that. Go design a transportation system. And quite frankly, what you're showing me is what I hope my students are going to come up with is the questions that they need to answer are, what are the jobs to be done? What are the assumptions which need to hold true in order to accomplish those jobs? And who else is doing it? And I show a video in my class of a Ford delivering a pizza and another one of GM delivering Walmart, an Equinox or something delivering Walmart packages. It's like, that's 4,000 pounds of vehicle delivering 200 pounds of groceries. Why do this, right? So you've got a good solution to that. My question is, I saw a lot of, and I should say my career started in vision-guided robots. What I'm not seeing is a specific list of what are the jobs that these things can do, or what are the jobs to be done that are solved by these things. And then what assumptions do you need to hold true? And to be honest with you, I'm not sure you should limit yourself to competing with pedestrians over pedestrian space, but maybe you need to start looking at competing over the automotive space. We have two types of pavement for at least 3 types of vehicles. There's the walking pedestrian, there's the driving car of 4,000 pounds at 70 miles an hour. And then there's this middle space that we haven't quite figured out yet, which is bicycles and scooters and the things that you're doing. So in any event, I realize there's a very broad question. It probably can't get solved now. My students take an entire semester to solve that to answer that question, right? But I at least thought I'd posit it out there and see what you think about it. So.
No, I think you're right. So there's a company called Refraction. They design these robots specifically which are running on a bicycle lane, right? Now, fortunately or unfortunately, not every place has a bicycle lane. So the moment there is no bicycle lane, the ODD changes and they are on the road. So that's a challenge there. So sidewalks, most likely, you find it everywhere, but still, that goes with sidewalks as well in certain cases. Now, in Middle East, we were, doing one of the pilots, and we realized that people were parking their cars, blocking the sidewalks as well. Right. So that is also an interesting, scenario where the sidewalks are blocked. I mean, what can we do? We just said that we can't do it here because the sidewalks are blocked, and you are not allowing us to go on the roads because we were talking to the government there. So I think these things are there. ODD has to evaluate, evolve over the period of time. Now, the second point which you touched upon was like the liability. I mean, this is something which is happening today with Tesla or other things where, so many things are happening. Now there, what I personally feel, and it is politically very difficult to get it done, but there has to be a standard where all the cars have to share their accident data, right? And if there is a way to do that, then judging a particular scenario or judging a particular product becomes easier. Now the problem here is, like, the government has said that give us like this data. Everybody is giving in their shape and form, and there's no direct just like how it happens in the airline industry, right? All the aircrafts need to give the data in the same format as it is expected, whether it is like Boeing or it is somebody else. So I think that standardization has to come in when it will eventually happen, and it's a big thing to move, because it is very complex from a commercial aspect, from of business. So I think that's a solution to that. So there's very common aspect where aircrafts, recently it happened with Boeing, where they recalled or they upgraded software. There was a security glitch in all the aircrafts which was running, right? So it goes back to the same question which you had, like, if there's something wrong in the product where it is autonomous, and most of the aircrafts are autonomous when they're after the takeoff, right? So I think that pretty much lies into the same periphery. So yeah, that's to that. So yeah,
we spent a lot of time on the 737 MAX as well. Okay, I'll stop.
I'm just.
We can have an offline discussion as well.
I'm going to give Jacob a minute, and then I have a question from Sai as well. So Jacob, do you want to go ahead?
Okay, thanks for the presentation. My question is quick. I was interested about the modularity of the backends. I wondered how quick it is to change those out. Is it the sort of thing that someone can load up the packages in it, put it onto a robot, and then take the one that was just off, and then use that one? So there's kind of two back ends to one robot that can quickly cycle out, or is it a bit more of a arduous operation?
So it is just the initial one-time operation which we do for a particular customer. We wanted to make it modular to a level where you can take the whole block, the compartment out. But the moment we give that flexibility, we also open it to a lot many other threads, where while the robot is moving on, somebody just picks up the entire box and moves away, right? So I think we need to. The team had this idea and they wanted to do that, but it was not possible, because then anybody can actually do that, and that becomes a challenge. So yeah, but good observation. I think we were thinking of doing that, but at the same time, what we did additionally, and I forgot to mention that in the recent versions, I mean, which we are going to put forward in Move America, which is a conference happening end of this month in Austin. So we are having these robots with screens on the front and back, where you can imagine that this is the next level of digital out-of-home advertisements. So which you just have a glance at the ads which are running on the robots moving next to you, and that gets into your subconscious to get some familiarity with that particular brand, right? So when it affects your buying decisions. So I think there's a lot more other things which are auxiliary to it, but I think there's no need for a standard for that, because that's a completely commercial aspect, right?
Yeah. Quick question from Sai Bantu. Are Autobots equipped with onboard units that can transmit V2X basic safety messages?
Yeah, I think we are. So right now, for us, since we are doing both indoor and outdoor, so in our software, we have like multiple devices which can be added interfaces to. So street lights is one, elevators is another one, automated doors are another one. Recently, we had a customer who wanted, like, automated doors is fine, but my doors are access controlled. Now, that's a very specific question. So we also have a solution which we are working with a company, where you have a long range RFID sensor on the door, and the RFID is on the robot, the card. So whenever the robot comes, if it has the access to that door, the door will open. If it doesn't have the access, it will not open. So I think infrastructure elements like these, like which we deal with, as humans, they are the same with these robots as well. So everything comes into one by one into the whole thing when we increase the ODD there.
Oops, Harshal, thank you so much, Ritukar. Harshal, you had lowered your hand. I thought your question was done, but maybe do you want to ask your question?
Yeah, that's fine. Thank you. Yeah, I would love to ask my question. So, Ritukar, as you mentioned earlier, that the governments are working with companies on V2X for autonomous autonomous vehicles, and also there are different infrastructure solutions for like smart cities, where they are trying to use detections to maybe send messages to the signals and to control the traffic signals. And do you think that similar thing can be done for PMRs as well? Because as you mentioned that there is no one to press the button for the traffic controller. So maybe that can be a possibility.
Yeah, I
Because
think
yeah, sorry. I'm asking it because I've already worked on some projects in my current company, and they governments are usually interested for having pedestrian detections and to automate those that process where even the pedestrians don't have to press the button, and we can automatically judge the crowd and let the traffic signal send a message to traffic signals. So maybe a similar thing can be applied here.
that's a good question, right? So who else cannot but press a button? So robot is one, which is very simple to identify. But at the same time, people with the special abilities, I mean, they might not be capable of pressing a button while crossing the road. So it is an accessibility question, right? So how can we automate? And there are certain BLE solution, Bluetooth based solution, which is not controlling the traffic, but they are just triggering events that, hey, I need to go, so showing the intent. So for pedestrian crossing it is like that. For triggering an event that I need to go, so if based on whatever traffic flow is, I mean, the system knows that somebody is there. So you're right. I mean, whatever works with people who could not press the button, that will surely work for robots. I think that's exactly what V2X solutions are doing. Available for elevators as well. Not everybody can press a button at an elevator. Say, elevator is high. You have to press 19th floor, and your hand cannot go, and you're on a wheelchair. What will you do? You have to have a solution for that, and people are working. And especially in Canada, there are a few places at the airports where they have an app with which you can control the elevator for accessibility. So I think those are the things which automatically overlaps into a better solutioning for everybody.
Yeah. Just to let you know, Harshal, there's an Austrian company called Swarco, and they wrote that system for the V2X, the SPAT and MAP specification, so that a robot can ask for the walk signal and receive that through the transportation system. So there's, at least that I'm aware of, at least 3 companies that are working on that problem.
Yeah,
we can talk offline about. I can connect you to those companies.
Thank you. And then Sai has one final question, which is, can you drive Autobots remotely if they're stuck in sidewalks?
Sorry, Autobots. Okay, yeah. They can be driven remotely as well. So as I've shown, like there is a fallback teleoperation software which we have, which is kind of becoming a very strong software, because not only just one robot, a single operator can monitor 10 robots, and out of those 10, whichever needs help just pops up that, hey, I need help. So they can directly go and take certain actions. One additional thing which we have understood is long back I had like some research papers at HRI, human robot interaction. So what we are adding is like how robots can interact in certain triggered situation. So even these teleoperation softwares which we have built in, so we are working on the mechanisms how we can use generative AI to have that context aware dialogue there. So I mean these things are there. I mean this is important, because sometimes stuck is the worst case scenario, but sometimes people are around the robot, and robot is saying please give me the way, but they're not listening, they're just playing around. So how can you be more contextual that, hey, I really need to go somewhere, and something else. I mean, depending on the context, if you can interact that ways, the robot respect points increase a little more. Yeah. So that's what we're trying. This is more HRI. We have to test and understand. But yeah.
Well, that brings us to a close. Thank you so much, Ritukar. I am blown away by how much you and the team at Ottonomy have accomplished in just 2.5 years. It's extraordinary, and we're so delighted to have you as members of the Urban Robotics Foundation. Thank you, everybody, for attending. We will be posting the video of this. I'll just do a little bit of editing, and hopefully I didn't cough anywhere on anybody during the talk. And Bern, do you want to make the final remarks so that I can stop
I'm impressed. We could go on for a couple more hours. We won't, but that would be, there's a lot of things I didn't know that you were up to already. I knew some of it, but not all of it. So thank you for all of that.
We are very happy to be part of URF, and this is the right area, right direction. So yeah, all good things are happening at the same time. Thank you, everyone.
Great.
Yeah.
I'll follow up with everybody with a final email. Thank you so much.
Thank you.
Bye-bye now.
Thank all of you. All right.